to the cloud. All right, so we have, thank you, Kate, for reminding us about the midterm. Midterm runs through Friday. I believe Friday is a late day. So if you wait all the way till Friday to take it, you will pay $5 for the privilege of taking the exam. So you'll want to get in there and take it today or tomorrow to avoid the late fee. Has anyone taken the exam already? How long did it take you to do? 44 minutes, kind of about what I expect, somewhere between half hour and an hour, about the same? Yeah. Somewhere there, okay. All right, this from Lord Acton, this is not so much to because of what this particular quote says as it is to introduce the idea or a different idea from the American founding. What made Americans who they were. In fact, this was the American founding value that probably emerged before any of the others. So when we say that feudalism made, what was it? Made land the major and the master of all things. If we think of the feudal society, where you've got 85 to 95% of the people who just work the land. They don't own the land, they work the land. And you've got another 4 to 8% of the people who are the nobility. They're the ones who are, their job isn't to work, their job is to fight, to protect the people who are doing the working. And then you've got the remainder, usually about between 4 and 8%, who are the clergy. This is really the way that society in Europe was structured for, clearly going back to the 1200s and even before. Now, we're getting a really interesting kind of new class of people, really beginning in the late 1300s. By the time we get to the 1600s, early 1600s, beginning of the American colonial period, we've got kind of a new class of people. See, if you're, the only avenue for you to become a landowner in feudal Europe is to inherit. It doesn't matter how much money you happen to make on your own somewhere else, you can't buy land. The only way land changes hands is through inheritance. But if your father landowner, and by the way, your father is going to leave that land to who? Yeah, oldest son. And that is everywhere except in what's today Germany. That was throughout Europe. That's the rule. And there's really good reasons for those kinds of laws. They're called laws of primogeniture. So what if you had 2 sons? What if you're the second son or the third son? You're not going to inherit land. What's your options? Well, most families would send one son into the clergy. And then the other place that you could go to have a reasonable career would be into the military. But now, by the time we're getting into the late 1300s, if you have a father who owns land, and not only owns land, but has money, then he could purchase a ship. He can outfit his other sons now to become merchants. And so by the time we get to the 1600s in England and more generally in Europe, many places in Europe, we have a whole merchant class. They are fabulously wealthy. They are usually have way more disposable income than the landed gentry, who are quite often, rich with land, but poor with cash. But they're second-class citizens. They want desperately to own property. There's no avenue to own property. Can they participate in the government? Can they be, in England, can they be, part of parliament? Yeah, we say it louder. The House of Commons. Yeah, even the language sets them as, they're not the nobility, they're not the lords. They can participate in the House of Commons. And so when the Virginia Company fails to find gold, which is why they went to Virginia, they're trying to find gold. When they can't find gold, and when the second thing they tried to make money at, making glassware, when that doesn't work, they finally turn, when they find out there's a plant that grows here in Virginia really well that they'll pay good money for in Europe. What is it called? Yes, tobacco. And once they realize that tobacco grows here, they think, oh, great, this is going to be our salvation. But the problem with tobacco, farming tobacco, takes a lot of people to farm tobacco. How are you going to get people to come from, there's a lot of people in Europe who know how to work the land. How are you going to get them to come to America? I mean, the Virginia company is going to go back to the investors and say, hey, we got it figured out now. We're going to make you wealthy beyond your wildest imagination. Sorry, the whole gold thing didn't work out. Tobacco is going to be the answer. We just need you to send lots and lots of people to help work the tobacco fields. The investors basically say, forget it, right? There's no more money. So, but Virginia has, what does Virginia have? Lots of. Virginia has land. They're defined from a certain latitude to a certain latitude, from the East Coast to the West Coast, wherever that may be. It sounds weird to say today, but most of Utah used to be in Virginia. Here, we're not in Virginia here, but you go to Nephi, that used to be Virginia. And so the Virginia company comes with the idea, they say, listen, we'll tell these merchants, these guys with ships that want land, and there's nowhere they can get it, come to America, we'll give you land. For every person that you bring to work in the tobacco fields, we'll allocate 100 acres. 50 goes to you immediately when they step off the boat, and then we'll hold 50 apart for them. If they can live the 7 years to collect, kind of finish their indenture, they'll get that other 50. If they die before then, that 50 goes to you, Mr. Merchant, thanks for bringing them over. And so for the first time in anyone's lifetime, now it becomes possible for you to come to America, work off the debt to get yourself here, and in your lifetime to become a landowner. You could start with nothing and become a landowner. And that is an unbelievable option. If we were to say, hey, come work over here, you get the same deal that you get from me back in Europe, which was work for me your whole life and never get anywhere. Oh, by the way, we don't know if we'll have enough food to make it through the winter, and the local inhabitants might rise up and kill us at any time. No one takes that deal. But see, you give them the same deal and say, by the way, if you can live the 7 years, you'll get 50 acres of land. That's a deal that almost everyone will take. As a result, through your labor here in America, you could improve your lot in life. That's not what labor does for you anywhere else in the world. If you are a laborer working with your hands, it is a sign of the lowness of your class, and no matter how good you are at it, you can never elevate yourself with your own labor, except in America. And as a result, labor it takes on a noble characteristic. That we think labor is noble in America, and that is not how they felt about labor in Europe. In fact, to this day, that distinction still exists pretty strongly. The American laborer is more productive than the European laborer. The American laborer takes half the vacation of the European laborer. The gap has closed dramatically over the past 100 years, but that was one thing that made Americans who they were, how they felt about labor. All right. Let's save that. Sure, let's go ahead and save that. Okay, so we have a file to download today. So it's called starwood2.xlsm. Go ahead and get that open. And this is just, this is some data from the Starwood Corporation. You probably haven't heard of the Starwood Corporation, but chances are you've stayed at one of their hotels because they're like a parent company. If you've ever stayed at a Sheraton or the Westin or the Four Seasons, those are all properties owned by Starwood Corporation. So what we have, we've got just a bunch of like addresses for properties here. Oh, and then here on the distance tab, this is like the road distances between all of the properties in the Western United States region for Starwood Corporation. And I don't have any reason to think this is a complete set of Starwood properties. It's just one that I found somewhere. And so if you want to know how far it is between the Sheraton Los Angeles Downtown Hotel and the Sheraton City Center Hotel in Salt Lake City, it is 691 miles. So that's what this table shows us. So today we're going to be talking about kind of a new idea, a new structure in VBA, something we haven't talked about yet, something called an array. So first of all, I'm just curious to know how many of you already can use arrays? Oh, just a small number of you. I know I can. Every time I get a paycheck, I look at it and say, boy, I sure could use arrays. There's not that many good jokes over here in VBA land, so we got to take the ones that you can get. Oh, thank you. You're too kind. Oh, stop. Okay. So I have to remember I've used arrays now so long, it just seems like a natural thing to do, but I have to remember my very, very first experience working with arrays. I think I may have told you this, when I was young, my father was a computer programmer. And so the truth is he was never really a very good computer programmer, and he was never really a very good teacher. And sometimes the combination of those two was just painful. And that was the case when he tried to teach me about arrays. And so he started off by explaining a metaphor, saying arrays is like having a bunch of pigeonholes. And I had a vague sense of what a pigeon was. You know, I was probably 12 years old at the time. I had a vague sense of what a pigeon was, some kind of bird that flies around and comes home when you ask it to. But I really didn't know anything about what a pigeonhole was. I guess it was some hole a pigeon lives in. And he tries to use this metaphor. Here's the first thing. If you're going to use a metaphor to explain something, the metaphor should be from a domain that the person you're trying to explain already understands. And that was not the case for me and pigeonholes. So, and then he, you know, after a half hour or so, and I clearly wasn't getting it, he said, okay, forget about the pigeonholes. Pretend that these are post office boxes. Now, I grew up in rural San Diego County, and I had been to the post office once or twice in my life by the time I was 12 years old. But when he said post office boxes, I was thinking of like the rural mailboxes that we have, post sticking in the ground that comes up and has got a tin, you know, box on the front. And so when he's thinking about an organized grid, I'm thinking about a bunch of different posts that are kind of, you know, all oddly enough, disarrayed would be the word that I would use to describe them. And so after about a half hour of that, I was completely confused about that. You know, I was in tears. I mean, my dad was in tears. You know, I mean, I thought, I can't believe I can't understand this. I must be a moron. My dad saying, I can't believe my son can't understand this. He must be a moron. And we gave up. We absolutely gave up. I didn't learn about arrays that day or maybe even that year. And the problem is that we often think about an array when we talk about an array as if it's its own structure, and it's not. Array is a word in the English language. You guys got your computers open. Someone just find me a definition of array. Just kind of look it up and tell me what's the definition of array. And one of you will kind of quickly find the one I'm after. It may not be the first one that you find, but okay, go ahead. What does it say? Ordered series or arrangement is pretty good. I don't like it so much though. What else we got? Go ahead.
Impressive display or range of a particular.
There we go. That's the one I want to hear. And impress, say it again. Yeah, say it again.
Impressive display or range of a particular type.
Okay, so don't lose that. I'm probably going to ask you a few more times to read that to us. So an array, just so the English language word, is an impressive, say it again. Display, okay, an impressive display or arrangement of a particular kind of thing. The important part here, it is of a particular kind of thing. It makes absolutely no sense to say, my, what a beautiful array I see. In fact, if I was to kind of look up here and say, my, what a beautiful array I see, what's the question you want to know? Array of what? What could be the answer? Could be an array of computers, could be an array of chairs, could be an array of students, could be an array of stairs. So it's a large, what is it? Impressive collection of an impressive display of a particular kind of thing, yeah. And so it's always a particular kind of thing. And that's true here when we're talking about arrays in any computer programming environment as well. Although we almost never say anything besides it's an array, we think somehow you must just already know what the array is of. And what is the array of when we talk about an array in VBA? We are talking about an array of, do you know? I'm not even sure our author does a good job with this. What's that? It's not an array of data. It's an array of variables. So when we create a variable, right, we're allocating some little spot in memory, we're giving it a name. When we create an array, we are creating an array of variables. We are creating a, say it again, an impressive collection, no, what was it? An impressive display of arrays. We are making an impressive display of variables all at once. So let's just kind of take a look at this, the idea of an array here like in VBA. So before we go into more detail on the example that we're doing, let's just go ahead and open up the code. Make a sub procedure here. DECLARE. Okay, if I was going to make one variable of type byte, I would say dim. Let me just go ahead and call this. I'm going to call this route as byte. Mute byte. Okay, how much memory is going to be allocated as a result of this statement? Might be helpful for the midterm. What is it? Yeah, the range is 0 to 255, and that's because that's what we can fit in 1 byte. That's then if we're storing integers, that's the number of different integers we can put into 1 byte. 256 different variables, numbered to 0 for 255. Now, what I can do here, if I want to make more than 1 variable, I want to make an array of variables, an impressive collection of variables. Oh, what was the word? It's not collection, impressive display, an impressive display of variables. I'm going to put a number right in here. So just in parentheses after the variable name, I'm going to put a number. And that's going to tell me I'm not just making 1 variable, I am making an array of variables. In this case, how many variables am I making in the impressive display of variables? And this is the tricky part because I'm actually making 101. What I'm doing is I'm establishing the top index here, and the array is going to start counting at 1. And so here I can say, and I refer to now all 101 of the variables in this array by the same name, route. But now I'm going to tell it which one I want. And I'm going to just I'm going to give the values to several of these. So route number 0. The 0th variable in the array is going to get a value, and then I'll put a few more in. We can't do that because I can only go to 255, so 56. I could now make a loop here for x equals 0 to 4. Actually, before we do that, let's just do a debug.print of route sub 0. What is this going to print? What will that print? Yeah, print 33, and then we'll do 54. And then we'll do 56. Because now it's like I didn't just create 1 variable here, I created 101 variables. And now the way I refer to them is by the name of the array of variables and a number to indicate which of the items in the array I'm interested in. So I'm filling up 6 of these. I'm only going to print off 3 of them. Wait, I'm filling up 5 of these. I'm going to print off 3. And so we should get 33, 54, and 56. 33, 54, 56. What's really magical about an array of variables is that when I want to refer to a variable by its name, I got to type out the name. Here, now I can use any expression that will evaluate to the integer that I want to tell which one I'm talking about, which means I can say for x equals 0 to 4. Next. And so now what am I going to, instead of printing route 0, I'm going to print route sub x, right? Because the first time through this loop, x is going to take on the value 0. And so it's going to print route sub 0, which is going to be 33. Second time through the loop, x will be 1. This will say, oh, print route sub 1. It'll print 100. So this should print 33, 154, 36, 3, and then 56. Questions? So when I'm creating an array, I am creating an array of variables. Oddly enough, arrays start counting at 0 in VBA. That's strange enough that some people say, you know what, wouldn't it be better if our arrays started counting at 1? Who thinks it'd be easier if arrays started counting at 1 instead of at 0? Yeah, I kind of agree with you. Well, it turns out that we can put in here another option. We can say option base 1. Option base 1 says, you know what, let's start counting our arrays at 1 instead of at 0. So now I'll have a problem if I try to write to the 0th position because there is no 0th position. So I'm going to comment out that line, and I'll have this one start counting at 1. And that should just start at 100 now and do those 4 numbers. If I try to refer to route sub 0, that's going to fail because subscript out of range. The subscript here, the 0, it's saying, sorry, that's not in the valid range because I told the interpreter, when you make an array, start counting at 1 instead of start counting at 0. We are not going to do that in this class. We are going to learn to deal with arrays as 0-based arrays. The reason is that if you learn, well, the first thing is that most often when you go look at someone else's code, if it's an array, it is going to be 0-based. That's almost always the way it is. It's really unusual to have arrays based as 1, even though it's an option here. The second thing is, if you learn how to manipulate arrays starting at 0, starting it with arrays that start counting at 1, it is really difficult to look at someone's code that starts with a 0-based array. However, if you learn to work with arrays starting with 0, it's really easy to make the shift to a 1-based array. And so I'm gonna do one that's a little bit harder to work with now because it'll make you better at this. Okay, question here?
Yeah, when you in route 100 as a byte, are you using 101 bytes of storage?
So then, does that actually use 101 bytes of storage? And the answer is yes. So I'm creating 101 variables. Each variable is 1 byte. Now, I would double that if I said integer instead of byte, right? So if I came here and said, no, this is going to be integer, because integer takes 2 bytes to store an integer, gives me range plus or minus 32,000. But yeah, so I'm making a certain number of that kind of variable.
So then, like, if you were to do string, and then you have it print out like the words that you have in each. What would that be, like, each string?
Yeah, each variable in the array. Okay, other questions? So I just don't think we need a metaphor to be able to talk about what an array is. It's an array of variables. You create a bunch of them. You refer to the individual variables in the array with the name of the array and the index number that says which one you want. Now, if you're thinking, it must be a little more complicated than this, the answer is yes. We're just getting started here, but that's kind of where we're headed. So are you ready to actually tackle a problem where I think using arrays makes sense? Let's go ahead and do it. Let's look at the problem. So we're going to suppose that you've just been hired by the Starwood Corporation, by the Western Regional Office of the Starwood Corporation. And your boss says, look, we're so glad to have you on board. None of our team knows you work for us yet. And so what I'd like you to do is before you show up for work the first day, we're going to rent you a van, some kind of nice conversion van or something. And you're going to take the family, and I want you to go to all 35 properties. Or is it 36? How many are there? I go to 37. We start to all 36 properties. And they don't know that you work for us. And so I want you to eat at all the restaurants, go to the pool, go to the workout room, go spend some time with the masseuse. We're going to give you a credit card, corporate credit card, just spend, and kind of keep track of, how these different properties are doing. Some are doing really great. Some are really struggling, but I want you to get out there and get to know them without them putting their best face on for you because you're someone who's coming from the regional office. And so, you say, great. So you got the van, you're taking the whole family. It's going to take you, probably a couple of months to get through all these properties. And so you're going to say, listen, well, what order do you want me to go to these properties in? And what does he say? What does your new boss say? I don't care what order you go to these properties in, but go to them all before you show up, at the office 3 months from now. Okay, so what order do you want to go to them in? If you could describe the route, what's the characteristic of the route that you want to be able to go to all these properties in? What would that be? You want to be the fastest or the shortest, the one that takes the least amount of time. Why? Because every hour in the van with the kids is 1 less hour with the masseuse, right? Yeah, you really want this to be the shortest route. Are you interested in the most scenic route? Probably not. just get me from point A to B to C to D in the shortest amount of time possible. How many of you are already familiar with this problem? This is a famous problem. This is a problem that mathematicians have been working to solve since the 1700s. Like mathematicians spend their careers on this problem. You know what this problem is called? It's called the traveling salesman problem. So it's like, if you kind of Google traveling salesman problem, there's lots of people talking about it. So you might think that our kind of like the collective genius of humanity has figured out some good solution to this. There is only one algorithm known to give you the shortest route. You know what the algorithm is? No, Amazon can't do it. Say it again. Okay, now actually pulling out a map and kind of looking at it is probably going to be your best solution to this problem. But we're talking about a computational solution. So given the road distances between all the properties, which is what we have here, what algorithm could I apply to that to say, aha, that's the shortest route? I know that I have the shortest route. There's only one known algorithm that will do it. We've been working on this since the 1700s. There's only one known algorithm. What is it? I bet you can figure out the algorithm if you give it some thought. Maybe not. Go ahead. Oh, okay. So what you've just described is one called the next nearest city algorithm. And the idea is start somewhere, say, what's the closest one we haven't been to? Go there. Then from there, find the closest one we haven't been to. Go there. Then it's an algorithm that we are actually going to implement. That's going to be what we're going to do. Start off in class today. We'll finish it next time we get together. It's virtually guaranteed not to give us the shortest route. It's going to give us a route, and it's going to be one that we can calculate. There's a lot of interesting things about the next nearest city algorithm, but it's not going to give us the shortest route. Any ideas of the but that's good. That's an algorithm. You did it. You gave me an algorithm. Hey, listen, I got to tell you, mathematicians have been working on this, spending their careers on this since the 1700s. They haven't figured it out yet. So don't feel bad if you can't pop it off the top of your head. Go ahead. No, you guys are trying to be too clever. Think more brute force about how to do this. It is the only known algorithm that's guaranteed to give us the shortest distance. It's calculate all possible routes and pick the shortest one. So just however many routes there are, calculate them all, add them up the distance between going this one, this one, this one, this one, nope, this one, this one, this one, this one, add them all up, and then just choose the shortest one. So is that a lot of different options here? What is it? I'm always surprised. Like, how many, let's see. I gotta see, how many do we actually have? How many properties do we have? I think we have 36. We have, 36. I'm always surprised that someone can tell me, if you've got 36 different places you're going to, how many actual different routes is it? So surprised. I don't think I've ever asked this question and had the whole class, so yeah, we have no idea how to describe that. 36 factorial. Someone always knows that answer. It's just amazing to me. You guys are bright. 36 factorial. Fortunately, over here in Excel, I got a factorial function. Fact 36. Never was very good with scientific notation. If I go big enough, will that actually show a number? Let's see. Let me go to comma. Don't need the, and I don't need the commas. There we go. I still can't say that number, but I kind of got a sense for how big that number is. So actually, when I first was making this problem, I thought to myself, I'll just write an algorithm that calculates all the possible ones. I know, it'll probably take a little while to run, but I can let it run, overnight or whatever, and it'll probably be okay. So my little computer at the time could calculate 5,000 routes per second. I thought that was pretty good, 5,000 routes per second. So let's find out how many seconds it would take. Take this and divide it by 5, 1, 2, whoops. This is going to be this divided by 5, 1, 2, 3. That's how many seconds. That divided by 60 is how many minutes. That divided by 60 is how many hours. This equals this divided by 24. Oh boy, that's how many days it's going to take to calculate. Pretty clear that my little computer is never really going to be able to solve this problem. So I read not too long ago that the 1 billionth PC has been produced. So let's kind of use that as a surrogate for the computing processing power of humanity. Let's take this, divide that by 1, 2, 3, 4, 5, 6, 7, 8, 9. That's how many days we put all of humanity's processing power to solving this problem. Let's divide that by 365. And if we put every computer in the world to solve this problem, that is how many years it would take. I still don't even know how to say that number. Best scientific estimate for the age of the universe. Anyone know? Go ahead. Yeah, we'll go up about 20 billion. So let's go ahead and take this number and divide it by 20. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's a number I can actually say. That is 100,000. That's 100. And so if we were to dedicate to solve this problem, to be sure we had the right solution, it would take 117 billion times as long as the universe has been in existence if we dedicated all of humanity's programming, computing processing power to it. That's amazing to me. It's kind of a simple problem to describe. It's only 36 properties. What's the fastest route to drive them? It's kind of odd here, but you could drive the worst route way faster than you could calculate the best route. You really could. So we're not going to try to figure out the best route, but we will implement the next nearest city algorithm. So you can imagine, what kind of companies today are interested in being able to solve this problem, who have to solve this problem repeatedly every day? Give me a name of a company that's really interested in the solution to this problem. UPS, Amazon, anyone who's delivering things. And by the way, it's more complex than we've described here because a left turn is more expensive than a right turn. So if you're trying to figure out what's the best route to go deliver your things, it's not just what's the shortest distance, but it's, I got to favor right turns over left turns. They're more expensive because they take a lot longer to do, and you're much more likely to have an accident if you're turning across traffic than if you're not turning across traffic. And so, yeah, do you get why this is a big deal? Yeah. Can you ask Google to plot like multiple locations? Can you say, hey, you know what? I'm making a route on Google. I want to put on a bunch of properties. Can you do that? Yeah. What if you put in 36? What would it do? It'd say, sorry, too much. It's just too much for us to do. So you can get, kind of up to a certain number. And once you hit about 25 properties, this becomes computationally impossible to solve. This is a fascinating problem to me. Okay, so here's what we're going to do. That's we've already kind of heard the algorithm described. So using this table that tells us the road distances between all the properties, what we're going to do. We're going to say start in Salt Lake. Salt Lake is the one that's closest to us. So that happens to be, let's see, property number on row number 3 here. And then we're going to say, look across this row. Let's see, to kind of look at this, because this is the diagonal is, the other half of this array is exactly the same, right? The distance from Salt Lake to Los Angeles is the same as the distance from Los Angeles to Salt Lake. So I'm just going to copy this one over here. And so if I'm starting in Salt Lake, I'm just going to have to find the smallest value in this row of the table, except for what? What's the value I want to skip? Yeah, 0. There's the 0. There's Salt Lake to Salt Lake is 0. It's not even shown here, but that's actually 0 there. I don't want to go to Salt Lake. I'm already there, right? So skip anywhere I've already been, and then just find the shortest one, then take me there. And then once we figure out how to do that, we'll do that over and over again. You ready to go ahead and do this? Let's go ahead and do it. All right, so here's what we're going to do to start. We're going to start by getting our data off of the worksheet and onto into memory. Now, so far, whenever we declared a variable, or in our very limited experience, declared an array, we've declared them inside of a subprocedure. Now what we're going to do is we're going to declare it in a different place. Whenever we declare a variable inside of a subprocedure, right when that subprocedure starts to run, the interpreter says, it looks across the whole procedure and says, what are all the variables that are declared here? It says, go allocate the memory for it. And then run through that procedure. And when we get to the end of the procedure, it goes, I'm done with all those variables. Release them back into the wild. Give that memory back to the operating system in case someone else needs it. But what we're going to need to do here is we're going to have 2 or 3 different subprocedures that we're writing that we all want to be able to go back and look at our set of arrays, the arrays that we're going to make to solve this problem. And so we're going to declare these arrays of variables with a different scope. And here's how we're going to do it. Instead of declaring them inside of a subprocedure, we're going to declare them outside of a subprocedure. So let's just take one array here, and I'm going to call it hotel. And we're going to have 36 variables in the array. By declaring it up here at the top of my module, it becomes a module level variable, which means any subprocedure in the module has access to it. If I declare it inside of a subprocedure, then only code that's inside that subprocedure has access to it. But now, in any code that's in this module, we'll be able to access this array. Okay, so it's a little bit different. And it's not because it's an array, it's because we're declaring a bunch of variables here that we want to access from multiple places. So make a subprocedure called init, short for initialize. And so what I want to do here is I want to just fill up that array with the names of the hotels. Ultimately, we're going to have to deal with the names of the hotels. So let's put them in kind of our first array to deal with. So if I was to kind of look visually at what I'm doing, over here, I've got an arrays sheet. This is, of course, this is actually a range on a worksheet. But this is a visual representation of what I want to create. I'm going to create an array called hotel. It is going to have 36 string variables in it, numbered 0 through 35, and I want to put these values in it. Now I'll read those off of my distance. I'm going to read them off of this sheet here. But this is what I'm headed towards building in memory. Okay, so we're looking at it here. This is just in memory what I'm going to try to build. We're okay with that? And the fact that it's already here on a worksheet is just so it's easy for me to talk about here in class. Okay. So by saying dim hotel 35 as string, I've built the structure. I now have 36 variables numbered 0 through 35. They're string variables. So what's in those variables right now, according to the code that I've written? Every variable has a default value that it starts with. These are string variables. What's the default value? Empty string. It's a 0 length string. Okay, so now, of course, I could do this by hand one at a time, but because I know how to make a loop, that's what I'll do. Let's look at it by hand first. Let's say hotel sub 0 is going to be equal to, let's see, what's the name of that sheet? The sheet is called distance, D-I-S-T-A-N-C-E. Starting at, let's see, distance is the sheet, so dot cells, row number, and where do we start on distance? Row number 2. Column number 1. We just go ahead and kind of do 3 by hand, and then we'll make a loop. Three, row 4. Go ahead and put a breakpoint here, stop, and run the code to that point. So now, if I just ask what's in hotel sub 1, I should get the Salt Lake City Sheraton. What's in hotel number 2? I don't remember what's in hotel number 2. It's the downtown Phoenix Sheraton. Now, of course, I don't want to have to write this out, even with copy and paste. I don't want to write it out that many times. So I'll make a loop. That's one of the great things about being able to create an array of variables is that I can use another expression that I can calculate to talk about which variable I'm interested in. So let me dim x as an integer. Actually, I'll do it as a byte, be big enough. And then make a loop for x equals. Now, I'm going to have a loop that I want to essentially be able to generate these lines multiple times just with a different value of the variable. So I'm going to have this one go from 0 to 35, and that will just let me drop x right into here. So for x equals 0 to 35, next. And now, by saying hotel sub x, I'm getting that same vector of numbers, right? This would be 0 through 35. Now, in this position, I've got to get this vector of numbers, which is going to be 2 through, what, 37? Anyway, it's going to be, how am I going to calculate? What am I going to change this expression to so that the first time through this loop, that's a 2, the second time it's a 3, then it's a 4, and so forth. Yeah, x plus 2, because x is going to count up already starting at 0, but we've got to be offset by a couple, so this will just be x plus 2. X plus 2. So now we don't need the ones we wrote by hand anymore, because the loop now will load all of those up. So now I should be able to look at hotel number 3, hotel number 30, hotel number 35, the very last one. And there they are, I've got them all. Okay, show me on a scale of 0 to 5, how comfortable are you with what we have done so far with arrays? 5 is like, I totally got it. 3 is, I'm following, but no way I could have done it by myself. Okay, so mostly 4s and 5s, go ahead.
Just the 0 to 35 in your for loop, that's what's doing the iterating.
So yeah, so the question is, what's this 0 to 35 doing? Is this what's doing the iterating? And the answer is yes. This is where I'm setting up the loop. I'm saying, what is the range that I'm going to take x across? So the first time through the loop, x is going to equal 0. Second time through the loop, x is going to equal 1. And it's going to keep going until x is larger than 35. So it will execute the last time with x equal to 35. It'll then increment it one more, take it to 36. And that's when we'll go, oh, I'm done. Other questions? Okay, we're going to do one more. Go ahead, question here, and then we'll do one more thing to make it a little bit more complicated.
So how do you eventually clear that information, right? So you have the hotel, the array is set up. Yeah, exactly.
So how do we eventually?
Does it ever go away?
How do we ever release that back to the wild? And the answer is, this now will get executed as soon as I run any code inside this module. And as long as I've got code running, it stays allocated. But when that code settles out and is done, then it releases the code, it releases the variables back to the operating system. So it's only really allocated while my code is running. But if I'm calling from one procedure to another, it stays allocated between them, and I can access it from each of those different subprocedures. Okay, now you can imagine that as I'm kind of going around to build this problem, well, yeah, I'm going to have to do this for the Western region. I'm going to have to do it for the Southern region, for the Eastern region, for the the Mid-Central region. I don't know what all regions there are. And so building this problem would be pretty great if I could just say, you know what, just drop in a new table of distances and then run it again. The trouble is that there's 36 properties in the Western region. How many properties is there in the Southern region? We don't know. Chances of it being 36, really, really slim. And so rather than have this thing hard coded to only work at 36 properties, and I'd have to change the numbers by hand, I'd like to make this dynamic. I'd like to make it figure out how big to declare the array. So here's what we're going to do. It turns out that because when we declare arrays, it happens before the code starts executing. When the memory gets allocated, before we start running the code. So we say, hey, run the code. Step one, great. Find out how much memory we have to allocate. You'll allocate it, and then we start executing code. So we can't just put some kind of a variable in here because that variable won't have its value until after this thing has to be allocated. So, so if we want to create what's called a dynamic array, an array whose size I can change while the code is running, then we don't say how many variables to create here. Instead, we leave that blank. So we just have an opening and closing parenthesis here. And that says I'm declaring an array of variables. The interpreter wants to know how many. And what do we say? I'll tell you when I'm good and ready how many. But at this point, you just get ready. I'm going to tell it to you sometime after the code starts executing. So this now is a dynamic array. So over here in my initialize, I'm just going to declare another variable here called hotel count. And we'll do that as a byte. So we're assuming that we're not going to have more than 255 hotels. That may be a bad assumption, but that's the one we're working with right now. So now, how are we going to figure out how many hotels we have? Well, let's assume that we're always going to be starting here in the second column, and that we could just do kind of an end down to find out how many cells we've got there. So let's do it here. Let's say, now that we've declared that, we'll say hotel count. Hotel count equals. Now let's look at our distance sheet. So we're going to do a multi-cell range. So we'll say range starting at distance dot range. What is it? A2. Yeah, A2. So that is the first cell in our multi-cell range. The second cell in our multi-cell range is going to be the one that we would be on if we were on that and we said end XL down. That will be the ending cell. And so we're just going to ask for the count of that range. Whew, kind of a long expression, and it's one that I can check without having to have my code actually running. And that gives me that number 36. So that's hotel count is 36. And what I want to declare this as is hotel count minus 1. But I think hotel count is still the variable I want to have. And I'll just offset it to get to the number that I want for 35. Questions on what we've done here? Right, so we're just saying, hey, start here, hold Control Shift down, and then count how many cells are selected. We're not actually selecting the cells, but that's the idea. So now I've got this dynamic array. What I'm going to do here is I am going to just dim it again. Dim hotel. And then I'll put here hotel count minus 1. The only trouble is that remember that dim actually gets processed before any of my code starts running. So I can't really dim it again, but there is an executable line called redim. And so I can redim the hotel to a different size. I do not give it a data type because I gave the data type when I declared it in the first place. So this is going to be a string array. The only question is how many elements will be in the array, how many variables will be in the array. And that's what we're going to get with redim. And so now we should be able to run this again, and it should produce the same information. So we should look at hotel sub 33, and that gives us something. Questions? So now instead of going to 35, instead of having the this hard coded here, it turns out you can ask an array how big it is. Now I could go to hotel count -1 because that's how I declared it, but I can ask how big an array is by asking the, it's called the U-bound, the upper boundary of the array, U-B-O-U-N-D, of some array. And that will tell me back what's the top index in the array. So I can use this expression here instead of 35 to make this now that we are, so this is now kind of fully configured to use whatever size of array I plug into it. That makes sense? So before we had it hard coded at 35, now we've said just calculate that it's going to be 35 and then ask how many times we have to iterate instead of having it hard coded. Maybe I should have done this example hard coded first because it would be less abstract, but this will be more useful to you. Okay, so we've got the first array that we need to be allocated. We've got two more arrays that we're going to use to solve this problem. Let's just go ahead and take a look at it. Back on my arrays sheet. Now, the way that I'm going to keep track of the route that we're actually doing, I'm going to do that with an array as well. Now, my hotel is an array of strings, the names of the hotels. This route is going to be an array of bytes, single byte integer variables. And so how am I going to use this array where I can only put numbers in here to establish what the route is? So I'm going to give you the starting point. The starting point is going to be Salt Lake City. It's going to be the Sheraton in Salt Lake City. That's property number 1 in our array. So how am I going to say start at Salt Lake City? If I'm using this array, how would I kind of establish this array? How do I say start at Salt Lake City? Yeah, hotel 0 is going to be the first one. Now, I don't actually want to put this whole string in here. Instead, I'm just going to put the index from the hotel array for that. So it's property number 1. So I'm going to say route number 1 is my starting point. From there, I know the algorithm well enough to know that we're going to go to Las Vegas next, which is number 7. And so the next step in the route is going to be number 7. I've taught this example a whole bunch of times. You'd think I'd know the third step, but I don't. Is it 19? Where is 19? Anaheim. I think it's 19. And so this is the way that we're going to build the route by saying, just take the index number that we use to keep track of the hotel name over here, and then we'll use those numbers to build out the route. So let's go ahead and, are we okay with that? Is there anyone who's saying, you know what, I'm not quite sure how this route whole thing is still kind of witchcraft to me? Question here? Yeah. So I've got all the names of these hotels right here, but I have a number that also refers to them based on their position in the array. So here's hotel number 0. It's this one in Los Angeles. Hotel number 1, this one in Salt Lake. Hotel number 7 is this one in Las Vegas. Hotel number 19 is this one down in Anaheim. And so instead of putting the names into the route, those names into the route, I'm going to put the number that corresponds to the route, to the name. So 1 is going to be hotel number 1. And I could always ask what the name of it is by saying, well, go to the hotel array and give me the number 1 variable, and it would tell me Salt Lake City. So just to simplify things, I'm going to use the number here to keep track of the route. So this says start at hotel number 1. And then the next place we're going to go is number 7, which is Las Vegas. And then we're going to go to number 19, which is Anaheim. Okay. So those numbers are just telling me, and it's just the arbitrary number that those hotels happen to get loaded into the hotel array. Other questions? All right, now let's go ahead and get our route array built. So I'm going to declare, I'll do the same thing. I'm going to declare it up above. And I'm going to call it route. This one is going to be byte, though. I'm wondering if byte is big enough. The whole idea is I'm not quite sure how big the problem is going to be. Am I ever going to have to deal with more than 256 different properties? If so, I should be using integer instead, but let's go ahead and stick with byte for now. Okay, so now I'm going to redim route the same way that I redim hotel. So it's going to be the same size. Now, because route is an array of numeric variables, each variable is going to have a default value. What's the default value? Yeah, it's going to be 0. So this looks like it's blank, but there's no such thing as a blank numeric array or blank numeric variable. So it really is starting off with a bunch of zeros. Now, remember that the algorithm that our student came up with, go to the next nearest city, we're going to be using the route to know it's actually go to the next nearest city that we haven't been to yet. How do we know if we've been to a city? I mean, based on the kind of way that we're building this problem to solve it, how can we tell if we've been to a city? Go ahead. Yeah, if the number that corresponds with the name is in the route array. So before we've started anything, our system is already saying we've been to the one in Los Angeles, right? What's hotel number 0? Hotel number 0 is this Los Angeles downtown Sheraton. And what does our route already say about the downtown Los Angeles Sheraton? It says we've been there a bunch. And so if our route starts off saying we've already been to that one, there's no, once we start asking, have we been to this city? It's going to say you've already been there. That's no good. And so what we're going to have to do here is we're going to have to get this thing to start off with some value that is not going to be any of my hotels. What should that be? Maybe my very top one. In fact, I dislike it so much now, I'm not going to use byte. I'm going to use integer. Because integer is going to allow me to put a negative number in there. But now I can put a -1 in there when I initialize this. So right after we initialize the hotel, we're going to set our route equal to -1. So we're going to go ahead and actually read a value to put into each one of the hotel, each of the variables in the hotel array. And then we're going to just put -1 into our route array. The reason is our lowest index number is 0. And so if we start this off with -1 everywhere, then we don't have to worry about any of our existing hotels already been there. A little bit of a thing to do. Microphone came unclipped and was dangling by my ankle. I hope the folks in Zoom could hear. Do we have anyone on Zoom saying, hey, we can't hear you? No. So I'm going to acknowledge that this is a little bit of a weird thing to do, but we're saying, listen, we want to make sure that we've started our route out without kind of accidentally saying that we're already been to some place. So when we ask, have we been there? It's going to tell us, truthfully, it'll tell us if we've been to the hotel or not, based on what number we have put into the array. We're okay so far? All right. We got one more array to build before we're ready to start using these arrays to solve the problem. This one's going to be a little more complicated. So far, our arrays have just been one-dimension arrays. We give it one index number, and it tells us, which variable we're talking about in the array. But arrays can be multi-dimensional. So we're going to make an array to hold our distance information. So here's our distance array, and it's going to not just be kind of a vector of numbers, but it's going to be a grid of numbers. So here's how we'll declare this one. We're going to make it a dynamic array. I'll just call it dist. Let's see. Yeah, I think dist will be okay. And this one will make, these are all integer values. So we'll go ahead and leave this one as integer as well. What's our largest value going to be in here? We get hundreds, up into the thousands, but we're not going to get 32,000 miles. Could we have like more than 32,000 miles between two hotels in the Western region? No, it's like only 3,000 miles across the whole United States. So I think integer would be okay for us here. Now, what we're going to do here is we are going to redim dist to be hotel count -1, comma, hotel count -1. So now we are giving it two sizes. We are making this 36 by 36, right? The range that we're going through is 0 to 35. So we've got 36 different values. But now in 2 dimensions. And that's because we gave it 2 values when we're declaring it. If I was to think of this just as declaring this as a static array, this would look like dist 35, comma 35 as integer. We're just calculating those values. So now we've got to supply 2 integers here. So if I want to refer to a particular one of those of the variables inside the array, I would say dist sub 5, comma 22 equals 344. I have to give it now two values inside of the range, 0 through 35 for the first one, 0 through 35 for the second one. It happens that for this example, we want this thing to be square, but it doesn't have to be square. Right? This could be 5, and then I'd supply a number between 0 and 35 here, and between 0 and 5 here. Does that make sense? So, so we're going to think of this as a grid. And so I just have to be consistent with the way that I, is it, which one do I give first? Do I give the row number first or the column number first? And the answer is it doesn't matter, as long as I consistently think of how those indices work. So if in my mind I say the first number is the row, second number is the column, as long as I always think of it that way, that's great. I don't have to think of it as a grid. I could think of it as 36 boxes that each have 36 boxes inside of it. So the first one tells which of the big box is it, and then the second one tells which of that big box, and the second one tells me which is the little box inside the big box. It's all just metaphorical anyway. I just have to be consistent about how I'm using the indices. I'm going to think of it in terms of row and column because that's the way that I think of anytime we do an ordered pair for dealing in a cell in VBA. It's always row and then column. And so, so it's going to be row column. Okay. Now, it would be kind of nice if I could just use this part of my worksheet because I've got to get both halves of the array filled in. But it's much more common to get this data in this format where I've got only one of the diagonals actually filled in. So let's go ahead and read the data off of this sheet to populate our array. I'm going to go ahead and make a separate loop. The truth is I could integrate the loop for doing the distance inside this loop, but I think I'll be happier if I kind of start again for dealing with the distances. So here we'll say load the distances. Add L Okay, so I'm going to make a loop here for x equals 0 to the upper bound of hotel. All right, and let's go ahead and fill in the first part of our dist array. So dist, I'm going to say the row that I want is row number 0. The column that I want is column number x. And that is going to equal my distance sheet cells Okay, so I'm going to go, I'm starting on row number 0. And I actually don't need to fill this in because this is going to be 0 already. Because this is an integer array, my distance is going to start off with all zeros. So I really don't need to set the value here because that's already 0 that I want it to be. So I'm going to go ahead and start here. So let's have this array go from 1 to the upper boundary of the hotel. So that'll go row 0, column 1, and we're going to read row 2, column 3. So I think it's just +2 here as well. So this is going to be row 2, column x +2. 2, comma x +2 dot value. Okay, now I'm right now only going across that top row. So let's just go ahead and see how that's coming so far. So I'm going to move my stop just before this, run my code. It should be next. And then I'll F8 through this. Okay, so the first time through here, x was 1. So dist sub 0 sub 1, sub 0, comma 1 should have put into row 2, column 3. Row 2, column 3. So it should have put 691 in there. And that's what I've got in that location. So we'll step again. And that should allow me to look at the number 2 position, 374, 374. It's looking pretty good. So I'll run the rest of the way out. And I should be able to look at that whole first row. So now if I look at the next one over 3, got 385. If I look at the very last one, it should be 35. I should have 1139. There's 1139. Now, if I look at the next row down, I haven't put any values in there yet. So right now, I've just got a loop that's gone across and read off this first row of numbers. Questions? Are we comfortable there? Show me on a scale of 0 to 5 how comfortable we are with the first row of data in that array. I'm asking, but I can't see you now. 3s, 4s, 3s, okay. 3 is probably an okay place to be at this point. This is brand new stuff and it's pretty complex. Okay, so now let's figure out how to get the next loop, or the kind of getting the rest of these to go. So now I want to make that code happen again, but to read this row here. So I'm going to need another variable. I'll dim y for this one. Dim y is a byte. And I just want this whole loop to happen over and over again. So I'll put this loop inside another loop for y equals And we're going to want to go from 0. Maybe I want to put it on the inside of this loop. Give me just a minute to think about this. Well, let's work through it. For y equals 0 to the upper boundary, kind of tab that structure in. So now I'm going to put y here. So instead of writing to 0, it's going to write to 0 the first time. We'll go through all of these, then it'll increment y, go to the next one for y, and loop across those as well. But now, instead of having x start at 1 each time, I just want it to start at 1 further than we are on y. So I'll read from all the way across here the first time, then we'll start here and read across and here. So instead of starting x here, we're going to make this start at y plus 1. So x isn't going to start at 1 each time, it's going to start at y plus 1 each time. So as y goes down, x is going to shift over. So we'll pick up we'll just be reading this data. Let's stop that and run this. So now I think we're in pretty good shape. As long as we're looking at the column that's bigger than the row, we should be able to get a value. So 135 should have its value in it. 1139, is that right? Looks like it's the wrong place. That's because this needs to be y plus 2. Now it's got 841, so we're getting that one. The next one down should be 1493. Okay, but, and it shouldn't matter which way I ask, between 2 and 35 or between 35 and 2, but because we haven't filled in this half of the diagonal, then those will all be zeros. So if I flip these two and do 35, 0, or 35, 2, that's going to give me 0 because it's in that part of the array that we haven't filled out right. The only thing we have yet to do to fill out this array is to say when we write to this location, column row 0, column 1, we want to write to this location, which is what? Row 1, column 0, right? I just want to write to the, I can get to all these just by flipping the indices. So after I write to this one, I should be able to say, just flip the indices here, and they should be able to fill that the rest of the way in. So now whether we ask about it that way, uh-oh, I hope we got this right. So if I flip this around the other way, it should give me the same number, yeah. Okay, so at this point then, we have filled up those 3 arrays so that they're now built to be in exactly this condition. Next time we get together, we'll actually implement the algorithm that says start at Salt Lake City, figure out the next closest one that we haven't been to, go there. Figure out the next one closest one we haven't been to, and then go there. That's as far as we're going to make it today. Questions? All right, thanks for coming. Class dismissed. Hello.
Question, but it's about the previous class.
Ah, excellent. Let me go ahead and get this saved. And turn off. Okay, go ahead.
So we did this, I'm like working on the project, and this was for, I think it was the 6th of October, so it's from last week. And whenever I try to run this up, it gives me this error. Yes.
It's expecting.
Oh, okay. I have to put something there.
It's 13 digits, so get it 13 digits.
Okay. Thank you. That's very helpful.
Hello, my child. How can I help?
I have a question about grades. On the fallen angel project, I turned it in sort of like boxes and wire. But my grade is still 4 out of 30 instead of the like 80%. So I was wondering.
Can you come up with my office right now?
Yeah.
Let me just go up there.
Okay.
I'll take minimum 6:13.
Okay.
Got 2 more minutes.
Okay. Sweet. Okay. I will go to
613.
613. Okay.
Question about the U bound. So I created a loop. It was just a do loop.